Okay, hello class. I hope by now you have read the assigned topics and you have already an idea what is slope deflection method. Okay, so just to recap, I have here a figure. This is a span AB of a continuous beam, and it is loaded with any kind of load. Okay, so a span AB can have end moments. At the left end, we call it MAB, and at the right end, we call it MBA. Okay, so if one of the supports will settle down, okay, at a displacement equal to delta, and if we draw the elastic curve of span AB, so maoning dotted nga line. Okay, so tangent at A, that would be our theta A, and tangent at B, that would be our theta B. So we call this slope at A and slope at B, and these are called angular rotations. Okay, so if we connect the chord between A and B, so a straight line A and B, the angle of that from the horizontal is called psi. Okay, and from our trigonometry, tangent psi is equal to delta over L. But since this angle is very small, so we can say that psi is equal to delta over L. Okay, so our concern here is to determine the end moments MAB in terms of the slopes theta A, theta B, and delta. Kining delta, gitawag po ni siya og linear displacement. Okay. The slope deflection method may be used to analyze all types of statically indeterminate beams and rigid frames. Okay. So in this method, again, the end moments acting at the ends of the member are expressed in terms of end rotations or angular rotations and the loading on the member. And all the joints here at A and at B, okay, are considered not to change in value as loads are applied. The joints at the interior supports of statically indeterminate beams can be considered 180 degrees, and for rigid frames are 90 degrees rigid joints. Okay, so for any member AB bounded by two joints, the end moments can be expressed in terms of the end rotations, and to satisfy the conditions of equilibrium, the sum of the end moments kaning MAB ug MBA on the ends of the members exerting there must be equal to 0. Okay, so in our sign convention, clockwise rotation is considered positive, and downward displacement also is considered positive. So clockwise rotation of the end moments positive, and also clockwise rotation of the slopes are also considered positive. Okay, from the derivation, we have now the slope deflection equation. So if this is the span AB, our slope deflection equation now is MAB equal to 2EI over L times 2 theta A. So kung AB dire, magsugod po ang theta A. 2 theta A minus theta B, I mean plus theta B minus 3 psi. Okay, so as we have said before, that psi is equal to delta over L. plus the fixed end moment AB. So on the other end, MBA is equal to 2EI over L times BA naman na. So magsugod na po ka sa 2 theta B plus theta A minus 3 psi BA plus the fixed end moment BA. Okay, if there is another span that continues from AB, let's say BC, okay, so our slope deflection for span BC will be MBC is equal to 2EI over L. So BC naman ni, so 2 theta B na pod plus theta C minus 3 psi BC plus fixed end moment BC. Okay, and MCB equal to 2EI over L times 2 theta C plus theta B minus 3 psi CB plus fixed end moment CB. Now, unsa man yung fixed end moment? So, ang imong mga span sa continuous beam, okay, ipang fixed end sa na nimo. So, ang mga fixed supports ang ilang ends. Okay? Now, at the back of your book, na ay mga formulas dito nga fixed end moments. So, here, ako lang gipakita. So, we have here fixed end moments, no? So, kung naa kay span AB, it is loaded by a concentrated load at the mid-span. So, ang iyang end moments will be kare sa left end o sa right end. PL over 8. No, kaya naman sa ito nga ang load. So, ang imong end moments will be counterclockwise at the left and clockwise at the right end, which is equal to PL over 8. Now, if the concentrated load is acting on the span but not at the middle, so any distance from A and B, okay, so ang imong end moments will be at the left end PAB squared over L squared. Okay, so sa left end, sugod ka aron di ka maglisod pag memorya. So FEM-AB is equal to PAB squared over L squared. Okay. And at the right end, so FEM-BA will be PBA squared na po dito. So PBA squared over L squared. Okay. Now, if there is settlement of the supports, there is delta. Ang imong end moments will be counterclockwise diri dool sa delta, and at the other end counterclockwise. So magparehas dili na siya counterclockwise. So that would be 6EI delta over L squared. Okay. So kung mabali pod ang imong displacement, okay, mo na imong fixed, diyan na diri ang displaced. So mo ani imong delta. So, may direction sa imong end moment. So, it will be opposite. So, mag-ana. Okay? So, this is FEM-BA equal to 6EI delta over L squared gihapon. Pero, ang direction is opposite. Okay? So, this will be FEM-AB equal to 6EI delta over L squared. Okay. Now, if you have a uniformly distributed load, okay, so ang imong fixed end moment is equal to WL squared over 12. Now, do not confuse yourself of beam with a simply supported beam and loaded with a uniformly distributed load. Ang iyang moment at the mid-span, no, M is equal to WL squared over 8. Okay? Say mo arab na kasaypan gyud sa mga estudyante, no? So, mao nang basta fixed-ended beam loaded with a uniformly distributed load, ang iyang moment at the ends is WL squared over 12. Okay, now if you have a uniformly varying load, okay, so ang imong highest intensity at the left end, okay, so that will be Fem AB WL squared over 20. Katong 0 nga intensity will be WL squared over 30. Kung mabali, okay, naana ang imong highest ordinate sa right, so ang imo na pong moment sa right end will be equal to WL squared over 20. And at the left end will be WL squared over 30. So you have to take note of these loadings. Now there are plenty of formulas at the back of the book. So napog kay fixed-ended beam nga loaded with concentrated load equally spaced. So this is L over 3, L over 3, L over 3. Nya equal ang ilang loads, no? So ang ilang end moments will be PL over, I think, PL over 9. And this one also is PL over 9. So I have to check lang this, no? Okay.